Number 1. Which object is formed when right triangle RST shown below is rotated around leg RS? Anytime I'm rotating a triangle, you will always create some sort of cone. But to visualize it, if I rotate this triangle around RS, RS isn't going to move. And I'm going to take T and I'm going to take it out of the paper, put it back into the paper, spin it around, and I would do that with all of RT and it would create that cone shape there. If you want to see it in 3D, here would be the image. That blue line is connected to the two red lines as a triangle. And if I spin it around the vertical side there, watch what happens. As I take it around and spin it, it fills out a cone with a point at the top and a circular base at the bottom. Number 2. A rectangle whose length and width are 10 and 6 respectively are shown below. The rectangle is rotated continuously around a straight line to form an object whose volume is 150 pi. Well, anytime I rotate a rectangle, if it starts as a rectangle and I rotate it around some line, it should always create a cylinder. And remember the volume formula for a cylinder is V equals pi r squared times the height. So if I wanted to go through each of these, let's say I rotate it around the long side and take this and spin it around like this. Visually what we'd have is we'd have a cylinder that would have a radius of 6, and the distance between those two circular bases would be 10. So if I plug into that formula using those measurements, do I get 150 pi? Let's check. The radius in this case would be 6, and the height's 10. If I leave it in terms of pi by just multiplying 6 squared times 10 in my calculator, I end up getting 360 pi, which is not 150 pi. If I instead rotate it using that short side 6 and rotate it around there, it would spin all the way around here and come back and create that cylinder. So to visualize that, the height of that cylinder would be 6, but the radius, the distance from the center to the edge, would be 10 units. So if my radius was 10 and my height was 6, 10 squared times 6 would give me 600 pi. Again, that's not the case. So let's try a couple other lines. The vertical line of symmetry, well, that would be right here. And if I rotate it and spin it, like if I were to spin an envelope on a table, it would just come around here, go back, and that would be the bottom base, and I've had a top base there. So in this instance, my height would be 6, and my radius would just be half of 10, or 5. So I'll try substituting it again. Volume equals pi times my radius squared times the height. 5 squared times 6 is in fact 150. So that would be the line that works. If I try to do it, just for argument's sake, for the horizontal line of symmetry, and spin it around there to create that cylinder, the radius would be 3 and the height would be 10. So when I plug into that formula, my radius 3 squared times the height of 10, that would get me 90 pi's of volume. So really this is just trial and error to figure out which one would get me 150 pi's of volume. Number 3, the cross-section of a rectangular pyramid contains the altitude of the pyramid. The shape of this cross-section is, well, let's try to rule some out. It's probably not a circle, given that there's no circle in a pyramid. And if I try to visualize it, here I've got a regular pyramid, and the altitude is the distance from the top point all the way down to the base in the middle. So if I cut it horizontally, that wouldn't contain the entire altitude. I'd have to cut it perfectly vertically right down the middle. Let's see if I can do this. Right about, it's not going to be perfect, but let's say right there. Where if I cut it right down the tip, it would make a perfect triangle. So try to visualize that. It's like if I had the pyramid, regardless of what shape the base is. The altitude goes from the tip at the top right down to the middle. And if I slice it vertically down that, I should always get a triangle. Number 4, which figure can have the same cross-section as a sphere? So it's helpful to know what the cross-section of a sphere would look like. And regardless of where I cut a sphere, that blue thing's the plane going through it, regardless of how I move that, it's always some sort of circle. Even if I cut off the top there, that cross-section is still a circle at the top. So the question is, which one of these would have a cross-section that's a circle? And the answer to that is a cone. If I cut that horizontally, I would be able to get a circle right out of any of those cross-sections. Picture this right here. If I take that plane and cut it parallel to that circular base, all of my cross-sections would be a circle there, which would be the same shape as the cross-section of a sphere. Number 5. A trophy has a rectangular prism as its base and a pyramid that lies on top of the prism. If the monument weighs 2.5 grams per cubic inch, what is the weight of the monument in grams? So let's say that this whole thing here is the monument. I would need to find a total volume of this base, total volume of the top, add them together, and then multiply it by the weight per cubic inch. Now everything's already in inches here, so if I find the volume of, let's say, that prism at the bottom, that's 10 by 6 by 2, which would be 120 inches cubed. That's just a rectangular prism. The top, though, is a pyramid. And the volume formula for a pyramid is 1/3 the area of the base times the height. Now, the base here is just a rectangle that's 10 by 6. So if I were to plug into the volume formula, the area of the base would be 60, 10 times 6, multiplied by the height of, what's the altitude of the pyramid? It's 9 units there. So the total volume of the pyramid would be 180 inches cubed. Now, total, my volume would be the sum of these two numbers, so 120 plus 180 is 300 inches cubed. But I want to know how much this whole thing would weigh. When it says the monument, it's talking about the whole thing. If I know that the monument weighs 2.5 grams for every cubic inch, I could multiply 2.5 grams per cubic inch by the number of cubic inches I have. My cubic inches units would cancel, and I would just be left with 750 grams as the total weight here. Number 6. A cargo trailer pictured below can be modeled by a rectangular prism and a triangular prism. So it looks like, I don't know if you've ever seen one of these, but the back part's a rectangular prism, and the front part kind of comes out to be a triangular prism there. The rectangular prism measures 6 feet wide by 10 feet long. The walls that form the triangular prism each measure 4 feet wide inside the trailer. The diagram below is of the floor, showing the inside measurements of the trailer. If the inside height of the trailer is 6.5 feet, so the total height of this prism is 6.5 feet, then what is the total volume of the inside of the trailer to the nearest cubic foot? Well, we could break this up into two parts. We could find the rectangular prism using this floor plan, and then the triangular prism, and add them together. I'll start with the rectangular prism, because I have all the measurements there. The base is 6 by 10, and the height of the total prism is 6.5. And all of those are measured in feet, so I don't need to do any unit conversions. So the volume of the rectangular prism is 390 cubic feet. Now, if I want to find the volume of the triangular prism, it's still the area of the base times the height, but remember, the base is a triangle. So in order to find that area, I need to know what the base is, which I do, it's 6, because the inside's a rectangle. But I don't yet know the height. So usually when I'm missing a part of a triangle, it's either going to be trig or Pythagorean theorem. but if that's the altitude, it cuts it evenly because the big triangle is isosceles. So I could use Pythagorean theorem on this triangle right here to find what that altitude is. So remember, that's a squared plus b squared equals c squared. A and b are the legs of my right triangle, and c is the hypotenuse that's always across from the right angle there. So if I solve that equation for x squared plus 9 equals 16, I could subtract 9 on both sides. And if I take a square root to undo the squaring, I find that that height is exactly radical 7. Now I could plug that into my calculator and get a decimal equivalent if I want to, but I'll leave it as radical 7 because that'll be a little bit easier to type in. So remember, the prism formula is the area of the base times the height of the prism. And the area of the base here is going to be 1/2 times the base of the triangle, which is 6, times the height of the triangle, which we just found to be radical 7. All of this right here represents that big B, the area of the base. The height that I'm going to multiply by is the same height of the prism that I use for the rectangular prism because they're the same height, they're connected. And when I plug that into my calculator, I get something that's about like 51.592 cubic feet. It says to round to the nearest cubic foot, but I'll wait till the end to do that. If I wanted to find the total volume, I could add these two, 390 plus 51.592, and then if I round that to the nearest cubic foot, I get about 442 cubic feet. So everything was already in feet. I didn't have to do any unit conversions, but keep in mind that if I don't know how to deal with the shape, try to break it up into shapes that you know how to deal with. Number 7. A rectangular tabletop will be made out of maple wood that weighs 49 pounds per cubic foot. Keep that in mind. It's per cubic foot, so I need a volume in cubic feet. The tabletop will have a length of 8 feet, a width of 3 feet, and a thickness of 1 inch. Well, instead of 1 inch, I'm going to divide that by 12 and just say that's 1/12 of a foot, because I know I need things in cubic feet here. Determine and state the weight of the tabletop in pounds. Well, let me do my best to try to draw this. It's a rectangular prism, because they say it's a rectangular tabletop, that's 8 feet long, 3 feet wide, and then it's kind of thin. It's 1 inch deep, so all around that height of the prism is going to be 1 inch, or 1/12 of a foot. So I'll start by finding the volume. Remember, that's area of the base times the height, or as you learned, at some point in middle school, for a rectangular prism I could just do length times width times height. And because all of those measurements are in feet, when I multiply them, I get a unit in feet cubed. So that's my volume, but I'm told that the weight is 43 pounds per cubic foot. So for every cubic foot, I've got 43 pounds of weight. So if I multiply those, my units cancel there, and I'm just left with 86 pounds as the weight of the table. So I took the volume and multiplied it by the density there. Number 8. A fabricator is hired to make a 27-foot long solid metal railing for the stairs at a local library. The railing is modeled by the diagram below, and the railing is 2.5 inches high and 2.5 inches wide, and is comprised of a rectangular prism, that's on the bottom there, and a half cylinder. How much metal to the nearest cubic inch will the railing contain? Well, if they want a measurement in cubic inches, one of my measurements is in feet here. So if there's 12 inches in every foot, I could multiply that number by 12 to find that that is 324 inches long of railing. All right, I need a total volume here. I'll find the volume of the prism, and I'll add to that the volume of the half cylinder. Starting with the prism, I know that it's 2.5 inches wide, 324 inches long. The question is, how tall is it though? Because they only give me that from top to bottom it's 2.5 inches. So let's assume that this radius and this height are equal. So if I take 2.5 divided by 2, that's 1.25. So the height of this rectangular prism is 1.25 inches, and the radius of that half cylinder when we get to it will also be 1.25 inches. So if I substitute all that into my formula, I find that the volume of the prism on the bottom is 1,112.5 cubic inches. Now everything's in inches here, so I know that's going to be my unit. For the half cylinder, remember the formula for a cylinder is pi r squared times the height, but if I want half of it, I can divide that by 2. And if I substitute in pi times the radius we just found, it was half of 2.5, so it's 1.25. And my height would be how long, or the distance between those half circular faces are. And it's the same length as the rectangular prism. That's 27 feet, or, 324 inches, because I want something in cubic inches. And whenever I get that number, I'll take half of it. I type that all into my calculator, and I get about 795.2 cubic inches. If I sum those, 795.2 plus 1012.5 is closest to 1808 cubic inches. So you got to read carefully to see if you're going to want everything in cubic feet, like we did for number 7, or if we want things in cubic inches, like they specified in number 8.